Okay, so today's lesson, we're starting chapter 6, all about probability. All right, and again, these are the terms we're going to go over today. So by the end of the lesson, you want to make sure you guys know all these terms in our checklist, and you can kind of work through the lesson and check off these vocab terms as we're going through our lesson. All right, here we go. So lesson 6.1, starting our probability chapter. All right, so for example, let's just start with, let's say hypothetically we're playing a game and we rolled 2 six-sided die. And we want to find the probability that they both land on sixes. Okay, so that's a possible situation. Or let's say a coin is flipped and we want to see what's the probability it lands on heads. Or let's say we go to the corner of, Huntington and St. Gabriel, and we look at the color of the next 20 cars that pass by. Okay, all of these are what we call chance experiments. Chance experiments. So a chance experiment is basically any activity or situation where we're just not really sure what the outcome is going to be, right? When you flip a coin, you don't know if it's going to land on heads or tails. So there's uncertainty about what outcome will happen. All right, so these are all chance experiments, and these are what we're going to be using to find probabilities. Okay, so for example, let's pretend we have a six-sided die, just like the one on the bottom right corner. All right, so the possible outcomes when we roll the die, what could come out is either a 1, 2, 3, 4, 5, or 6. Okay, so if I list it out like this is what we call the sample space. The sample space. So a sample space is the collection of all possible outcomes of a chance experiment. All right, it's the list of all possible outcomes in a chance experiment. So for rolling one die, this is our sample space. All right, we use capital S for sample space. All right, and this is the notation we're going to be using. So this is what we call set notation. All right, questions on sample space? All right, so if we were to find the probabilities of each of these outcomes and we were to add them all together, hopefully it's not surprising that it would add up to 1. All right, because if it's a sample space, it's all the possibilities, right? So it would be 100%, or 1 would be the probability of getting anything in the sample space. All right. So here's another example, all right, with no numbers, all right? So this is flipping 2 coins, flipping 2 coins. So the possible outcomes are you can get heads, 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 tails, tails, heads, or tail, tail. All right, so this is another example of how to write the sample space. All right, so now there's another way to write this out, and that's using a tree diagram, a tree diagram. Show of hands, how many of you guys have seen or done a tree diagram before? Oh, a few of you. Oh, perfect. Nice. Okay. Oh, that was more than I was expecting. Cool. All right. So for those of you guys who didn't raise your hand, if you aren't sure what a tree diagram is, this is a tree diagram, for example, of the same situation. I think about my first coin and I think, all right, I can get either heads or tails. All right. So that's where it branches off to these 2 options for the first coin. Then I think, well, if I get heads on my first toss, I could still get heads or tails on my second toss. Right? So that's where these branches come out from the first toss, being heads. Or if I got tails on the second toss, or on the first toss, I can still get heads or tails on the second toss, right? So then I get 2 branches coming out of the tails. And how you read this is you just follow the branches to show the outcome. All right, let me show you that one more time. So this is considered one outcome, heads then tails. And if you were to follow the branches on all of them, you get heads, heads, tails, heads, tails, tails, in addition to that one. All right, so then you end up with the same sample space as what we have above. All right, any questions on tree diagram? All right, this is a great organizational tool that we'll definitely be using later on. All right, continuing. Let's say we're going back to the die, and I specifically want the outcome of an even number. All right, I don't know why, but I like even numbers better than odd numbers for some reason. And I just want to know, all right, what are the outcomes if I want an even number on my die? So here I have it listed, 2, 4, and 6. Those are the outcomes that are considered even. So this is a specific part of the sample space. So this is what we call an event. An event. All right, so an event is any collection of outcomes, specific, right? Specific outcomes in the sample space. So it's like a subset of that sample space. Notation-wise, we usually use capital letters. I use capital E for even. Okay. And yeah, that's an event. All right, now let's say I want the opposite. Let's say I want to know what outcomes would be in the event that the die is not an even number. What outcomes would be in the event that the die is not an even number? What do you guys think? What outcomes? Not an even number.
One, 3, 5.
Good, yes, 1, 3, 5. All right, so these are the outcomes in what we call the complement. All right, the complement of the event. So the complement consists of all outcomes that are not in the event, but still the sample space. All right. So imagine like you have the sample space, you subtract out the event, right? You take out the 2, the 4, the 6, whatever is left is your complement. So that's the 1, 3, 5. All right, so this is the complement. Notation wise, notice the C superscript, capital C superscript for complement. This is the most common notation, but just a heads up, you might see, I don't know, somewhere in your book, maybe E prime or E with a bar over it. That also represents complement. The superscript C is the most common one though. Oh, also side note, do not confuse this with complement as like an I in the middle as opposed to the E, okay? This isn't like compliment like Jeff, your hair looks spot on today. Okay. Don't confuse it with that kind of compliment with an I. This is the one with an E, okay? Though your hair does look fantastic today. You're welcome, you're welcome. Okay, so yeah, compliment, just think opposite. Compliment means opposite. All right, any questions on that one? All right, cool. Hopefully it doesn't surprise you that if you were to add the probability of the event and add the probability of the complement, it would always equal to 1. Because when you combine those, you get the entire sample space. All right, so let's look at this. Visual learners, this is really for you. Let's look at the Venn diagram version of this. All right, so Venn diagram. First off, did you guys know that the rectangle that you make around the Venn diagram circles actually means something? Yeah, it means the sample space. It's not just a pretty frame for you to put your Venn diagrams in. It actually represents something. So always have a rectangle to represent your sample space. And your circles will be your events. Circles will be your events. So if the area inside the circle represents the event, the area outside the circle represents your complement. All right, so hopefully that makes sense. All right, any questions so far? Okay, let's move on to the second page of our notes then. All right, so next up, we're going to talk about the union. All right, so suppose we have two events. The first one, we're still just talking about evens in rolling that one die. And let's say we introduce another event, P, for prime. All right, so 1, 2, 3, 4, 5, 6. Out of those numbers, the prime numbers are 2, 3, and 5. By the way, 1 is not a prime number. All right, that's a common misconception, but 1 is actually not a prime number. All right, now if I want to know about E or P happening, all right, if I want the event of E or P happening, these would be the values in that event. All right, so any number in E or any number in P would satisfy E or P. So this is called the union of two events, the union of two events. So definition-wise, the union of A or B consists of all outcomes that are in at least one of the two events. It just needs to be in at least one of the two events, meaning it can be in A, it can be just in B, or it can be in both. All right, and this is the notation. All right, it's pretty easy, right? U for union, U for union. All right, so I don't know about you guys, but when you hear the word union, all right, like outside of math, what do you guys think of when you hear the word union outside of math class? What pops into mind?
Marriage.
Marriage, yeah. That's what I was thinking too. Somebody from my other period said they think about like the teachers union, which I was like, oh, I actually think of that too. But yeah, I think of like marriage, like a union of like two, star-crossed souls, whatever. But yeah, I think of like marriage. So like for me, I got married, like in my 30s. And so, I had a lot of stuff. Right? I just had a lot of stuff from like living on my own, living in my own apartment. I had my own microwave, had my own like spatula, bed set, towel sets, all of it, So I lived on my own. So, and so my husband also, he lived on his own and he had all his stuff. So, well, what happens when we got married, right? When we unioned? Well, that's me. That's my husband. Here it is again, in case you missed it. That's me. That's my husband. So what do we do with our stuff? We pull it together, right? So now we have 2 spatulas. Okay. So we just pull all our stuff together and we live happily ever after. Okay. So that's the same thing with the union. All right. So going back to E and P, right? Let's say E is me, P is my husband. Oh, which actually works out. My husband's name is Philip. So we pull all our stuff together, right? We both had 2s. I had a 4, he had a 3, right? I had a 6, he had a 5, and we put it all together, and now we are a union, right? We're all together. So that's what's in our union. All right, so that's just kind of a fun example to help you guys remember that. Okay. All right, Venn diagram wise, let's see what this looks like. Here's E. Here's P. Notice 2 is in both. So 2 is in that intersection of the events E and P. If I want to shade the event that represents E or P, Where do you guys think I'm going to shade?
In between the two circles.
Like just this sliver right here?
Both
No,
circles?
both circles.
Yeah, good. Yeah, both of you guys, good job. Yeah, both circles. So this would be the shaded region of E or P, right? Doesn't matter which circle you're in. You can be in one, you can be in the other, or you can be in both. All of that satisfies E or P. Nice, guys. All right, sweet. Any questions on union? All right, let's go to intersection then. All right, intersection, E and P. This time, I want to find out what do they have in common. All right, what number is in both? And in this case, the number 2 is the only number that occurs in both E and P. All right, so that is the intersection of A and B. Notation wise, upside down U. Upside down U. All right, so in this Venn diagram, where would you shade? In this Venn diagram for E and P, where would you guys shade?
In the middle.
Just the middle. Yep, just the overlap part. Good. All right, and that is the intersection. Okay, so I just want you guys to realize that this is actually super intuitive, right? It's actually super intuitive. So for example, let me go to Diana Wang. All right, Diana Wang. Are you currently dating anybody? Oh gosh, that might be too personal. Okay, pretend for a moment you're not, okay? I don't know if you are, if you're not, but we're gonna say that you're not, okay? Even if you are. Now, Diana, when you are considering a male suitor or female, I don't know, what, okay, Malika's like totally laughing. What, okay, now I'm getting all flustered, Malika. Okay, let's say this. Do you want to date somebody that's cute?
Yes.
Okay. Do you want to date somebody that's smart?
Yes.
Yes. Okay. So let's say, Diana, you're saying like, I want to date somebody that is cute and smart. Cute and smart, right? All right. So let's say someone comes up to you and they're really cute, but they're not the brightest, not so smart. Would you date option number 1?
Yeah.
But you said you wanted to date somebody that's cute and smart.
But
So if they're cute, not so smart,
oh yeah, then no.
you wouldn't date them, right? Because they're cute, but not so smart. So you're like, no, I want to date somebody cute and smart. All right. What if option number 2 comes up and not the cutest, but he's really smart? Would you date option number 2?
No.
No, right? Because you want cute and smart. All right. Option number 3 comes up. Cute, both cute and smart. Would you date that person?
Yes.
Yes, because they meet both criterias. So then you're like, yes, we are good. We can go out. Okay. Now, Diana, let's say your, how should I say this? Let's say your standards have started to slide. Okay. Let's say, I don't know, you're just like, you know what, we're just gonna go easy a little bit. All right, we're gonna let the standards slide a little, and we're gonna say you're like, you know what, I'm okay dating anybody that's cute or smart. Cute or smart. Option number 1 comes by again. He's cute, not so smart. Would you date him?
Yeah.
Yeah. Right. What about option number 2 comes up? All right. Smart, but not so cute.
Yes.
Yeah. What about option number 3? Cute and smart. Would you still date him?
Yeah.
Yeah, definitely. Right. So I just kind of want to show you guys that this idea of and or is really intuitive. Like you guys naturally understand and or, right? And the difference between the two. All right. So thank you, Diana, for letting me use you as an example and make Malika laugh uncontrollably. Okay. So hopefully that's a, way for you guys to kind of realize, all right, you get and or. You get it. Okay, moving on. All right, our last vocab term. We have these 2 events, A and B. A is just the event that a 2 is rolled, specifically, just a 2. That's the event. B is the event that a 6 is rolled. Okay, so now my question to you guys is, on a single die roll, is it possible for A and B to happen at the same time? Can I roll a 2 and a 6 on the same roll? All right, I'm seeing people shake heads. Good. Yeah, it is not possible. All right, I'm glad nobody is just like, oh, well, the die can land on the edge. Okay, no. All right. So yes, you cannot roll both a 2 and a 6. So this is what we call mutually exclusive events. Mutually exclusive events, also known as disjoint events. And by the way, those I've seen both of them used. There's no like favorite. Okay, so make sure you know it either way. Mutually exclusive or disjoint means that the 2 events have nothing in common. There's nothing in common. So like even in prime, those were not mutually exclusive events because they shared a 2. All right, but these 2 events, they don't share any common outcomes. So if you guys were to imagine the Venn diagram, what would that look like? What do you think? I have a little box there for you at the bottom right. What do you guys think the Venn diagram would look like for disjoint events? I know this is a little tricky.
Would you have like both only the 2 and 6 and then like they're separate circles?
Good. Yes. Nice. They're separate circles. Exactly. There's just no overlap between those circles. Good. And that's how you would see mutually exclusive events. All right. Good job. I think we have made it through our checklist so far. Any questions? All right, go through the checklist, see if you need any clarification on any of those terms.
Can you just kind of explain event a little bit more? I don't really understand.
Yeah. Yeah, the event is basically any like subset of the sample space. So when you're like looking at you're trying to find something very specific in your situation. Like I specifically want to see, even numbers, or I specifically want prime numbers, or I specifically just want 2 or 6. Those are all events because they're subsets, like specifics in the sample space. Does that kind of make sense?
Yeah, that makes sense. So it's not just like any numbers that you get, it's specific ones?
Yeah. So if we're talking about any of like the whole, list of outcomes, that would be the sample space, right? But then if I want like specific, outcomes, that would be an event.
Okay. Thank you.
Yeah, no problem. Okay, any other clarifications on any of the vocab terms? All right. If not, let's go ahead and practice this kind of understanding of it with Venn diagrams. All right. So what I want you guys to do is on the last page of our notes, you have 4 problems regarding Venn diagrams. Okay. And this is to this example about, SMHS. And some students are enrolled in statistics, some in calculus, some in band. And you can also enroll in multiple ones, right? You could be in statistics and calculus. You can be in statistics and band, calculus and band. So yeah. And so I want you guys to go ahead and we're going to make Venn diagrams to represent these following events. All right. So for your 4 problems, go ahead and let me switch this around. Draw a box first to represent, the sample space. All right, ooh, that was a lot thicker than I thought it'd be. All right, so draw a box to represent your sample space. And then we're gonna draw 3 circles. All right, 1 for statistics, 1 for calculus, and 1 for band. Okay, and then go ahead and label these. All right, so we'll label this, I think this one's statistics. This one I labeled calculus. And this one I labeled band. All right, so go ahead and do that for all 4 problems to kind of just set it up. And then we'll shade based off of the problem. All right. So let me go ahead and I'll start us off with the first one, and then I'll have you guys practice maybe with the last 2 or 3. Okay. All right. So for the first one, it says calculus or band. Calculus or band. So when I'm thinking of calculus or band, right, I'm thinking, all right, that means anything in my calculus circle, which is all of this. All right, so anything in my calculus circle, which is all of that, or band, right? So anything in this circle, or anything in my band circle. All right, and that would be my answer for the first one. Okay, any questions on number 1? Yeah, all right, that's it. That's it for number 1. Okay, let me actually show one more. I'll have you guys try the next 2. Let's do statistics or band and not calculus. Statistics or band and not calculus. Okay, so for this one, I'm thinking, all right, statistics or band would be these 2 circles, and I would shade the whole thing just like I did number 1, except I want nothing with calculus. So I don't want anything inside my calculus circle. So I am looking at just these regions right here. All right. So statistics or band would be both circles, but I'm going to subtract out anything in the calculus circle. All right, so that would be my answer for the second one. All right, any questions on this one? Okay, then why don't you guys try 3 and 4, and then we'll check answers and see what you get. All right, this was the answer to the second one. All right, here we go. So the answer to the third one looks like this. All right, so this is statistics and band, not calculus. All right, so it's this intersection part of statistics and band, but taking out anything in the calculus circle leaves you with just this piece right here. All right, show of hands if you got that right. Show of hands if you got that right. Ooh, nice. All right, good job, guys. Okay, last one was a little different. This one says statistics and not band or calculus. All right, so this is your final answer. Statistics, all right, so anything in the statistics circle, but nothing that is in either the band circle or the calculus circle. So subtracting out the calculus, subtracting out the band, leaves you with just this piece. All right, show of hands if you got this one correct. All right, a few of you, good. Okay, good job, guys. That is it. Any questions on these?